Let's tune the telescope in to galaxies being born. And oh my gosh, who ordered this? We're finding galaxies in the dark
In the
ages.
vastness of the universe, nothing has captured our imagination like its birth. The Big Bang Theory has dominated the stage of cosmology for decades, providing an apparently indisputable explanation for the origin of the universe. But what happens when this theory is called into question by a groundbreaking discovery? Welcome to Universal Narratives, where we will delve into the depths of space and time to explore a mystery that is shaking the foundations of our cosmic understanding. Without further ado, we present to you the incredible phenomenon revealed by the James Webb Space Telescope, the discovery of 750 new galaxies that challenge everything we thought we knew about the origin of the universe. The scientific field is in a continuous phase of evolution, where new discoveries modify and shape our understanding of the cosmos. Neil deGrasse Tyson is one of the most prominent voices in this scientific dialogue, but other revolutionary developments have also come to light, bringing with them revelations that challenge the theory of the Big Bang, which has long been considered unshakable. One of these fundamental developments concerns the James Webb Space Telescope, which has revealed the existence of approximately 750 galaxies, each of which defies our previous expectations and understanding of the characteristics that galaxies should possess. This telescope was specifically designed and built to help us understand the origin of galaxies, so its revelations are of fundamental importance and compel us to reflect and reconsider existing theories. This incredible instrument has captured astonishing images that shed light on some inconsistencies in the Big Bang theory. For example, the sizes of the observed galaxies contradict the expectations based on an expanding universe. According to the Big Bang, at the beginning of the universe, all matter, energy, and fundamental constituents of the cosmos were compressed into an extremely small and densely concentrated point known as singularity. Singularity is a point of infinite density, where matter and energy were compressed to such an extent that they reached infinitely high density values. This concept stems from our current understanding of the laws of physics, particularly from the equations of general relativity proposed by Albert Einstein. In singularity, all the matter and energy of the universe were in a state of extreme compression, implying that an enormous amount of mass and energy was concentrated in an infinitely small space. But under these conditions of extreme pressure and density, the temperature reached unimaginable values, higher than any temperature we can observe or reproduce today with our technology and knowledge. The point of infinite density represented the seed from which the entire universe would develop. Thus, the moment of singularity marked the beginning of the universe as we know it, representing the origin of everything that exists in our cosmos. From that moment, the universe began its journey of expansion and inflation, a process that lasted approximately 13.7 billion years, leading to the universe we know today. The expansion began with an incredible explosion known as cosmic inflation, during which the universe expanded at an unimaginable rate, surpassing the speed of light. This played a crucial role in the formation of cosmic structures, such as galaxies and stars, that we see today. However, despite these elaborate and accepted theories, the images captured by the James Webb Space Telescope have challenged the traditional understanding of the origin of the universe. Our current cosmological model is based on the assumption that the universe is continuously expanding, a process that continues to this day. This expansion can be observed through various phenomena, such as the redshift of light emitted by distant galaxies. This redshift indicates that as the universe expands, light waves stretch, shifting their wavelength towards the red end of the spectrum. These observations are crucial for understanding the evolution of our universe and shed light on how galaxies have formed and developed over time. The detailed and breathtaking images captured by the James Webb Space Telescope have introduced new questions and dilemmas. The observed galaxies appear too small, too smooth, too old, and too numerous compared to what we would expect in an expanding universe, as described by the Big Bang theory. The reduced sizes of the observed galaxies sharply contrast with what the theory predicts, revealing a discrepancy that requires further investigation and reflection by the scientific community. Singularity is a concept that directly arises from currently accepted laws of physics, particularly Einstein's equations of general relativity. In the depths of this singularity, it was believed that all matter and energy of the universe were in an ultra-compressed state. The introduction of new galaxies that seem to challenge these fundamental physical laws necessitates a comprehensive reevaluation of our existing theories. It is conceivable that there have been errors or misunderstandings in our previous interpretations of the data or in the way we have constructed our theories. The observed new galaxies challenge not only the predicted sizes but also their age. According to the Big Bang model, at the beginning, all matter and energy, including the building blocks of the universe, were confined to an infinitely small and dense point, a singularity. However, some of the galaxies observed by the James Webb Space Telescope show stellar populations that appear to be over 1 billion years old, a finding that contradicts the timeline of the Big Bang. These seemingly incongruent discoveries with our current understanding of the cosmos raise urgent and crucial questions. What does it mean when we observe galaxies that appear too old for our current cosmological timeline? Do these observations perhaps indicate that there are aspects of the universe that we still do not fully understand? In light of these revelations, it is crucial not to jump to hasty conclusions, but rather approach these mysteries with an open and inquisitive mind, ready to question and, if necessary, reformulate existing theories that we have taken for granted. Science is a dynamic, ever-evolving process, where new discoveries can quickly overturn existing consensus and lead to new, groundbreaking understandings. One of the answers may lie in exploring alternative or complementary theories, such as the cyclic universe theory or the steady-state theory. These perspectives offer different explanations for the origin and nature of the universe, and may provide the conceptual tools needed to interpret and understand the astonishing observations made by the James Webb Space Telescope. For example, the cyclic universe theory suggests that the universe goes through continuous cycles of creation and destruction, with each cycle ending in a big crunch and beginning with a big bang. This theory would imply that the universe does not have an absolute beginning or end, but is eternal and dynamic. The old galaxies we observe could be relics from a previous cycle, somehow escaping destruction and carried forward into our current universe. Similarly, the steady-state theory proposes that the universe did not begin with the Big Bang, but has always existed in a constant, steady state. According to this theory, matter is continuously created to maintain a constant universal density, even as the universe expands. In conclusion, the new and extraordinary discoveries made by the James Webb Space Telescope prompt the scientific community to critically reassess the Big Bang theory and consider alternatives that can explain the observed incongruities. As the era of discovery continues, we remain at the frontier of knowledge, navigating through mysteries and wonders that the universe continues to unveil to us. With a humble and curious approach, open to the infinite possibilities that science and research can offer, we can expect to uncover further secrets of the universe in the decades to come.